Is anyone online right now? Okay, Ishan. Good. Morning, Ishan. How are you doing?
Good. How are you?
Great. So just wait for a minute. So just want to wait for more people coming.
Sure. Yeah.
So I'm sure that Essen told you about this, right?
Uh,
Or you
wait,
just
what?
saw that on School Loop?
Oh no. It was in the group chat. I'm not sure who sent it,
Oh, okay.
but I saw it on School Loop, but I didn't see the invitation on School Loop.
Oh,
So
okay.
yeah.
Did you watch my YouTube channel?
Yeah, I do sometimes.
Okay, cool. So I heard about like this year, you guys only be tested with the free response, and there's no multiple
Yeah.
choice. And then everything it's all up to whatever the teacher is covering to March. So probably there's no sequences in series, but Mr. Bryan covered that already. So we'll talk about that too.
All right.
Yeah. So what have you been doing? Studying?
Yeah.
Yeah.
A lot of studying, and then yeah, there's not really much to do.
Okay.
What about you?
Yeah, kind of busy. So always put up lessons online every day.
Nice, nice.
Mm-hmm. So how many AP classes are you taking this term?
This term,
Mm-hmm.
I have AP History and like BC right now, and then I
Uh-huh.
did AB and English in the first term, and I'm self-studying econ.
Oh, self-studying econ?
Yeah,
Wow.
it's like I
Good.
think it's 4 tests total.
Uh-huh.
It's
Pretty
calculation.
impressive.
Yeah, but econ's not too hard, so it's like is it's easier than like anything in school.
Right, right. Okay, let's see the waiting room. So far it's only you and I. Okay, let me. Okay, we got Arthurine. Hey, how are you doing, Arthurine? Morning.
Good morning, Mr. Chen.
How have you been doing? Good?
Good. Good. How are you?
Good. Okay, let's see. So we got 4 people so far. Let's see.
Yeah.
How you doing, Jeb?
I'm doing good.
Did you guys do any like practice tests already in Mr. Bryan's class? Like the one for the previous year?
We did
Oh,
like practice FRQs, and then we did a couple of like just random MCQs, right?
Okay, like a random and okay, the multiple choice.
Yeah, like
yeah.
not from like a specific section not from like a specific test. We just like
Uh-huh.
randomly
What
put
about
together.
for this one, the one that I'm sharing the screen with you right now? Can you see that? It's a
Oh
Yeah.
yeah,
2019. Did you guys do this already?
No.
No, not
no.
yet. Okay, so that's why I'm going to be doing some analysis for this one. Because I really want to show you the way to read through the problem and then digest to figure out the way to solve for all the
Mhm.
problem here.
Okay.
Because sometimes, some people, they're kind of like overthinking it. But, the key thing is that it's all about the reading comprehension and also applying, what you learn in calculus. Yeah. Okay, let's see. Okay, so now let's get started. Can you guys read through the problem? Is that clear? Or you want me to enlarge that?
It's like it's a little blurry.
It's
Yeah,
a little
like,
blurry. Okay, let me enlarge it. Okay. Let's say 120. What about right now?
It's like a little better.
Okay,
Right.
let me just make it. Okay, 150 maybe.
Yeah, that's good.
It's good?
That's good.
Okay.
Yeah, that's good.
So guys, just read through this one here. So we do have two equations here. One is the entering, and then the other one it's the leaving.
Mhm.
Okay, so the first question it's asking about, okay, so the number of fish entered the lake over the 5-hour period from midnight, t equals 0, to 5 a.m., so t equals 5. So give the answer to the nearest whole number. Okay, so I'm just wondering, so what do you guys would do with this one?
Take the integral
Take the integrals for which function?
for, what is it, e minus L?
Yeah.
E minus L? Okay,
Oh, wait,
keep
is
that
it?
in mind. It's the enter. Okay,
Oh, so
the
it's
keyword.
only e then, right?
Yeah, so it's only E then. Okay, so the
Okay.
keyword, again, got to be careful. Okay, E minus L, we'll deal with that later. So this one, it's about the number of fish entered the lake over the 5 hours period. So that means it's just what? Integrals from 0 to 5. And then E of t. So this one, basically, you can do that on the calculator.
Yeah.
Okay, so you know how to do that on the calculator, right?
Yeah.
Yeah.
Okay, cool. So basically, enter the function and then just take the integral, math integral from 0 to 5. So that one is pretty easy to set up. Now, what about the next one? So what's the average number of fish that leave the lake per hour over the 5-hour period? Okay, so the keyword, can someone tell me about the keyword for this question here?
Average number.
Average number, very important. Okay, average number. So what would you do?
You do 1 over
Average
5 minus 0, and then the integral
Okay,
of L.
1 over 5 minus 0, okay? And then integrals of L of t. And the time is from what? 0 to 5 once again, right?
Mm-hmm.
Okay, good. So basically that one, you just do it on the calculator, you'll see that it's going to be the rate. So try to do that on the calculator. Eventually, you're going to end up with 6.059. But also you need to put in the rate. I mean the unit. So this one will be fish per hour. Okay, so now let's take a look at the next one. Wait, anyone? Any questions that you have so far?
For B, why would it be fish per hour if it's asking for the average number of fish?
Just fish, right? The fish that leave.
Well, because that's just the unit. It's just the unit rate.
Oh, okay.
Okay. And then the next one, at what time from 0 to 8? And the greatest number of fish in the lake. And justify the answer here.
So wouldn't we just do like the derivative of E minus L?
Okay, so the derivative of E minus L. Okay, so this one,
And then we would do like the maximum thing. Like
yeah, well, this one, it's not
lined up.
yet. Okay, so this one's the greatest number of fish in the lake. So basically, you need to set up the new function for this one.
Yeah.
Okay, so this one you want to set up the new function. So let's say this one it's f of t. So we just want to set that as e of t minus
Oh,
L
I
of
don't think
t.
you're
nothing
right.
here. It's not showing up. What you're writing is not showing up.
Oh, what
on
I'm
the
writing
screen.
is not showing up there.
No, it's not.
No.
What about for the previous problem?
Yeah, it worked.
Yeah, the previous.
Okay.
Okay, yeah, now it's showing up. Now it's showing
Okay,
up.
now it's
Yeah.
showing up. Oh, because the network is not being stable. Okay, so now it's showing up, right? Okay,
Yeah.
cool.
Yeah.
Okay, so now after you set up the new function, so now how do you justify the how do you find the greatest number of fish in the lake? I mean, not the greatest number, just find the time for the greatest fish. So Alphavin is saying that taking the derivative, but this one it's not about the derivative yet. I mean, you can say that this one is just f of t equals e of t minus L of t. So basically, you want to
Or you
set
could
that
just
as what? Equals
straight
0.
up graph it. Yeah.
Set it equal to 0, and then you solve for the time.
Right.
Okay, let me just put in another student here. Again, this one is asking about the time. Okay, because the function is already showing the rate model. Okay, keep that in mind. It's the rate model, so there's no need to take the derivative yet. So basically, you just need to subtract those two functions, the entering and then the leaving. Okay, because they are both representing the rate already.
Okay.
Okay.
That makes sense.
And
That
then you
makes
set it
sense.
equal to 0. So now you guys know how to solve for this on the TI, right? Or do I need to show you that on the TI?
Could you show us?
Yeah.
Yeah, definitely. Okay, so let me open up the app here. So give me one second.
I have an idea how we might be able to get back the birdie from the other side.
Because there's an easy way to find the zeros on the calculator. Okay, so instead of putting the functions, finding the max, the min. Can you guys see the screen, the one that I have right now, the calculator screen?
No.
No.
No. Okay, let me share that screen right here. A new share. Okay, what about right now?
Or like the authors he brings
No.
The authors he talk or the scientists he
Okay,
brings up.
let's check that
Upper
again.
Davis.
Can you see the calculator screen?
No.
No, not yet.
No.
But it's like kind of a little bit
That's
after.
strange. Because I put in the new share. Okay, let me try that one more time.
Recollects about or like reflects on it, and he's like.
Okay, what do you see on the screen right now?
That they were like outdated.
It just shows the
Just the
FRQ
problem.
still.
So, like,
Yeah.
proof of
Okay,
false,
so just that.
very different. So it kind of shows like how he kind of values the past, but also like how kind of not as many people believe in it as they used to.
Can I see the calculator?
No.
Yeah. Okay, let me just stop sharing this one here. And let's see. Okay, what about now?
No.
So you still
It
see the
just says you
PDF file?
started screen sharing. No, I just see like a black screen that
Yeah.
says Kenny has started screen sharing.
That's strange. Okay, let me just do that one more time. New share. Let's try this portion screen. Okay, what about right now?
No, it's still the same
No.
screen.
Still the same screen? Okay, let me see. Okay, what about this?
No.
Okay, so now let me just go back to the PDF file.
Oh, wait,
For
we
the
can see it.
Oh, you
calculated
see it
part.
now.
We can see it.
You see it now?
We can see it. We can see it.
Okay, you see it now? Okay, cool. Okay, so now what you need to do, you need to enter the function first. Okay, so try it on the calculator. So one it's considered E of t, and the other one it's what? L of t, right?
Mm-hmm.
Okay, so once you enter the functions, and then the next thing that you want to do for y3, you want to subtract those two functions, y1 minus y2. Okay, let me show you how to do y1 minus y2. Okay, so let me just pull out the key history here so we can follow through this. Okay, let me just delete all this one. Okay, so now if you just want to enter that y1 minus y2, so you want to go to vars, and then you go to y vars. Okay, so just follow the key history right here, vars, and then the right cursor, go to y vars, and then you see that it's highlighted in function. So press 1. So you see that y1, y2, so one thing at a time. So y1 first, and then minus y2. Again, same thing, vars, y vars, and then function, and then y2. Are you guys on the same page so far?
Yeah.
Okay, cool. So basically y1 minus y2, so that gives you the new function, and then from there you can find the zeros. Okay, so now the next part of this, so you want to go to the graph. Now before you click graph, make sure that you go to zoom and then standard, because you want to put in the standard window for the graph. It's just for y1 and y3. I mean y1 and y2 for the function of y3. If you see more than one graph here, so let me show you something. Well, up to the graph right here. Do you see more than one graph, or do you just see one graph?
I see all of them.
One.
Okay, so here's what you need to do. Go back to y equal. You see what I did here? y1, y2. I didn't even highlight the equal sign. So you can always unshade the equal sign. So the way to unshade it, simply
okay.
go to the equal sign and press enter. Because you just want to focus on y3.
Okay.
Okay, got it? Okay, so
Yeah, I got it.
unshade the equal sign for y1, y2. So just leave that with y3. Again, go back to zoom and then standard. And now you're looking for the 0. How do you find a 0? Anyone?
Do second and then calc.
Second calc? Okay, well, remember, it's the time, so the time cannot be a negative number. So this 3 solution right here, so we're not allowed to have a negative number for the time. So the only solution we have is right here on the positive x-axis, right? So second trace, and then 0. Okay, so you want to bring down the cursor. So just move that all the way to the right. So this one is going to be the left bound, right bound approximation. Okay, so it's getting there. Okay, so that's the left bound. Do you guys see the point here?
Mm-hmm.
Okay, and then press enter. And then right bound, so that means it's underneath the x-axis. Right bound, okay? Anywhere underneath the x-axis. And then press enter again. Okay, so here's what we found. Is that what we got?
Yeah.
Okay, so that means at time equals 6.203 second, and then you'll get the maximum fish entered to the lake. Okay, once again, the internet, it's a little bit unstable. Okay, so now let me go back to the PDF file screen. So you guys can see that. Okay, let me go back there. So any questions that you guys have so far? The way that I did on the calculator?
No.
Okay, so now let me go back to the PDF file. Okay, so can you guys see the screen?
Yeah.
Yeah.
Okay, cool. So now the next one is the rate of change in the number of fish in the lake increasing or decreasing. So now guess what you have to do this time?
Take the derivative.
Exactly. Take the derivative of E of t minus L of t. And then you just want to plug in the number, right? At t equals what? 5. If that's greater than 0, that means what? Increasing. If that's less than 0, then that would be considered what? Decreasing.
So what do we write for like our reasoning?
The reasoning here, you just need to show the work. Okay, so by the time that, for the previous one, for C, so by the time that at 6.203 second, no, hour, excuse me, and then you just want to compare that the rate. So you want to show that the rate, okay, so let me just write it down here. You can say that since, okay, so this one is for C. So you can say that since E of t, it's greater than L of t. So for 0, it's less than or equal to t, and it's less than a. So then f of t is greater than 0. Okay, excuse me. So this one, let's see. So for f of t is greater than 0, and for 0, it's less than or equal to t, it's less than a. And then the other way, well, just another thing you can do is like a line test. So another thing that I can do, you can set up the line test here. So the time that we find out, what is it? It's about 6.203. So just want to plug in a number. Anytime that's less than 6.03. So this one, it shows that it's considered what? It's positive. And then the other side here is what? Negative. So remember that the graph is that going this way, positive to negative. So what do you notice? So that shows the what? The max. So it's kind of like a derivative test, okay? But this one is called the line test. Okay?
That sounds good.
Or I mean, you can write a statement if you want, okay? You can write a statement like what I do here. And then the last part is actually pretty straightforward in order to find out whether that's increasing, decreasing. So just take the derivative and then plug in the time. If that's greater than 0, so that means it's positive. If the rate, well, if the derivative is less than 0, that means the rate is going to be considered decreasing. So anyone, any questions that you have so far regarding the first FRQ?
No.
No.
No? Okay.
Wait, just
so now,
wait,
Yeah.
Mr. Shen, just for C, we also have to plug in the endpoints, right? 0 and 8 when we're looking at the
yes, you
the
do.
greatest
You
number
need
of
to plug
fish,
in an
just in
endpoint
case.
because that is
Okay,
finding the
cool.
greatest number. True.
Yeah, okay, just making sure.
Yeah. So just want to test that. Yeah. Because the one that we found, it's kind of like a, what is it? The relative max. So you want to find the absolute max, you need to test the endpoint as well. Good job, Optimus. Okay, so now let's move on to the next one. Okay, so now it's a polar graph. Now I'm sure you guys did this one already.
Wait, like, do we have to like work on polar graphs because they removed it from the AP test? I'm just saying.
Well, it's going to be part of it. You know, guarantee that's going to be part of it on the test. So you guys not that
Wait,
confident
really?
with the polar graph?
I
Wait,
mean, it's because they removed it. Like, wait,
Yeah.
you can go ahead.
They
have-
because of the new changes to the test, they released an update saying polar and parametric won't be on there anymore.
Oh, polar and parametric won't be there? Okay, we can skip that part then. Okay, so now let's see what else that we have then. Okay, what about this? Now, let me tell you that for the free response, the first 2 problems, they're always considered calculator. And then the last 4 problem for the free response, they're all like non-calculator. Okay, so now take a look at this one here. So this one shows the graph of the function of f of x, and it's continuous. I'm sure you guys know that's a piecewise function. And this one, it runs from -6 to 5. And you might be wondering, wait a minute, it looks like it's being cut off here. for the other part of it, it's actually given. Okay, so let's read through the entire instruction. So this one shows portion of the graph only, and that consists of the 2-line segment. Okay, 2-line segment, and then it's a quarter of a circle, center at a point, 5, 3, 5, 3 right here. That's the center, and also the point at f3. So f3 here. So the y value is 3 minus root 5, irrational number. Okay, so now the first question. So if the integral from -6 to 5 f of x equals 7, find the value of the integral from -6 to -2 and show that the work lead to the final solution. What would you do?
Wouldn't you do like the FTC thing? So it'd be like the integral of from -6 to 5 f of x equals the integral of -2 to 5 minus or plus
Right.
the
Yeah,
integral.
we need to separate them. Exactly. That's what we want to do. So integrals from -6 to -2, well, to 5. So you want to break it apart, right?
Yeah.
Okay, so break it apart. And this one, f of x. So that equals the integrals from -6 to -2, f of x. And then plus the integrals from -2 to 5, right? F of x.
Yeah.
Okay. So now one thing that we notice, this one is what? It's given already, it's 7. So now, can someone tell me about the integral from -6 to -2? Well, that's what we need to find out. What about the integral from -2 to 5? How to get that area under the curve?
Isn't it like you find the area of the triangles and then
Exactly.
quarter
Find
circle?
the area of a triangle, the one above the x-axis, the one down below the x-axis. Okay, let me just show you that. Okay, above, below, right? All that, all the area. Okay, well, here's the triangle as well. Should put a line segment here. Give me 1 sec. So let me put a line segment to cut this off. Okay, so this part, okay, 1 triangle, 2 triangle, and here's the 3rd triangle, right? And then we need to find the area of this region as well. So basically just using the geometric concept to find the area, right? So now, if someone can tell me about the area of the first little triangle here, it's a right triangle. So what's the area for this triangle?
0.5.
So that one is just 0.5, right? Okay, so that one is just 0.5. Okay, what about the area of the bottom triangle here? So this one, it goes from -1 to, looks like it's what, 1/2? So the base would be considered 1.5. And then the height, that's 1. So what's the area of this triangle? Now keep that in mind, it's negative because it's underneath the x-axis. So it's 1/2 times, well, 1.5, that's 3/2. And then times the height. So then that'll be, well, this one is going down, so let's say it's -1. Okay? And now the area of the other right triangles. So what about the area of this triangle here? Anyone? So the
It's like
base considered
2.25,
what?
right?
Yeah, so the base is also 1.5. But what about the height? The height's what, 3, right?
Yeah.
So 1.5 times 3, and then times 1/2, 0.5. So basically just add all the area, the shaded area under the curve. Okay. Again, the one above the x-axis, the area, it's always positive, and the area under the x-axis, so then that'll be considered negative. Now, but what about for the quarter of a circle here? How do you find the area of this shaded region? Anyone? For those who were taking geometry freshman year?
Pi r squared over 4.
Okay, so find the area of the quarter of a circle, right? And then find the area of the square, and then you subtract. So the area of this whole square, then that'd be considered
9.
9. Okay. So 9 minus quarter of a circle. So 1/4 pi r squared. So what's the radius here?
3.
3. Okay. Good. So once you calculate all this, okay, so let's see. Eventually, I'm going to end up with, just want to make sure that the answer is right here. Okay, give me 1 sec. So once you calculate the number, so the area for this one, and also you subtract from 7, because that whatever the area that you have, you want to subtract from 7. So it's going to be considered 7 minus whatever the whole thing that we have right here. And then I'll end up with 9 pi. Well, the rest of that is just like a simple arithmetic. So basically just compare, combine the like terms and then try to simplify it. Okay, any questions?
No.
Okay, good. Anyone else?
No.
So far, just
No.
hear Atavin and the other person is speaking up. Okay, so any questions, just stop me right here. Okay, so now the next one, how do you evaluate integrals from 3 to 5 and then 2 times f prime of x plus 4? So this one is only from 3 to 5. So from 3 to 5. How do you set that up? Okay, so anyone, any thought?
We could like split up the integral first, so the 4
Okay,
is
split up the
added to
integral
2.
first. Okay, so let's just split up the integrals. So this one, it's integrals from 3 to 5. And then the 2, that's just a coefficient. We can just put it out. So f prime of t.
Yeah.
So we want to find out what f prime of t is from 3 to 5. And then plus integral from 3 to 5. And then 4,
Plus, yeah.
right? Like that.
Mhm.
Okay, so what's f prime of t from 3 to 5?
Well, isn't the integral of the derivative just f of t?
Yeah, just f of t, right? So basically just integrate it.
Isn't it just f of 5 minus f of 3 then?
Yeah,
Or
f
whatever?
of 5 minus f of 3. So that one, it just consider 2 times f of 5 minus f of 3. Okay, and then plus, what's the integrals of 4? And that's just
4x.
what, 4x? And then from 5 to 3, right?
Mm-hmm.
Okay, that one's just from
4
5
minus 12.
5 to 3. So basically just find out what that is. So f of 5, which is 0, right? According to the graph right there.
Mhm.
Okay, so here showing that it's 0. And then what about f of 3? F of 3 is actually given. It's
Yeah,
3
3
minus
minus
root 5. And then the rest of that, again, it's just about the fundamental theorem of calculus. So 4 times 5, 20. And then 4 times 3, 12. So 20 minus 12, which is what, 8? And then basically just combine the line term once again. So what do you think so far? Does that make sense?
Yeah.
Yeah.
Okay, good. And now for the next part of the question here, so this one might be a little bit difficult. Okay, so now what do you think? So the function g is given by g of x from -2 to x, f of t dt, and find the absolute maximum value of g on the interval from -2 to 5, and then you want to justify the solution. Okay, so anyone, any thought?
Find a derivative, so the integral cancels out, so then you're just left with f of x, and then you make it equal to 0, and then do the
Okay.
line graph.
Yeah, but this one, you actually want to find out the absolute maximum value. So basically this one, you want to compare all the area. Well, let's find out the zero first. So according to the graph, so let me go back to the graph right here. So the zero that you can find out, which is what, -1. Over here, what is that? 0.5, right? And then over here, 5. Okay, let me just write down the 0 according to the graph. Well, because the 0 shows the what? The breaking point. Okay, so this one shows the breaking point. So it started at -1. And then the 0 that we have for the next one, then that'll be what, 0.5. And then the third one, which is 5. So basically you just want to compare the area from -2 to -1. And then from -2 all the way to -1. Well, just find out all the area. Okay, so start off from the area, -2 to -1. And then -2 to the next position, 0.5. And then find the area from -2 to 5. So you want to compare that, which one will give you the maximum, the highest value for the area. Well, eventually you'll see that the area from -2 to 5 will give you the largest number. And that's the one we'll say that F5 will give you the maximum area. So that means the answer, just like going back to the first one. So just find all the area there. So eventually this one will give you 11 minus 9 pi over 4. So basically this one is just a comparison. The comparison of all the interval area. So started from -2 to -1. So this small triangle here. And then -2 to the position of 0.5. Okay, so the total area. Well, that would give you the negative number. And then the final area, it's from -2 all the way to 5. Okay, so that's what the question is asking. So again, absolute maximum, that means the highest value. And that will give you the, the highest position of the graph after you integrate it. Okay, any questions?
No.
Okay, anyone else?
No, I'm good.
All right. Okay, so just want to see that any student that's not from Kennedy right now, or you guys all from Mr. Bynes' class?
Yeah, we're all from Balance.
Yeah.
Okay, good. Because I put in the one on School Loop. It's like anyone it's invited. So far we do have 9 people. Okay. Okay, so now what about the next one? How do you find the limit? So 10 to the power of x minus 3 times f prime of x over the quantity of f of x minus r tangent of x. So how would you take the limit for this?
Plug in 1.
Just plug in 1, right? Because that so far there's no restriction. Okay, so just plug in 1. So 10 minus 3. What's the derivative at 1? Let's take a look at that derivative at 1 right here. So what is that about? What's the rate of change of this line segment? If someone can tell me about that, rise over run. Looks like the rate of change for the at 1 would be what? 2, right?
Yeah.
Would that be 2? Because that's what? 4 over 2, rise over run.
Mm-hmm.
Okay, so just plug in 2. And then f of 1, what's f of 1? Okay, let's go back to the graph again. F of 1, so that's just 1, right? So that one is pretty straightforward. But the thing is that what's r tangent of 1?
Pi over 4.
Pi over 4. Okay, good. And then basically this one just calculate it. So 10 minus 6, 4. 1 minus pi over 4. So 4 minus pi over 4. And then simply just reduce, cross cancel. If that's happening, well, nothing can be cross canceled. So it's what, 16 pi? No, 16 over the quantity of 4 minus pi. So that one's pretty basic. Okay, so now, any other questions so far for number 3 of the FRQ?
For part C, how would you justify your answer?
Okay, again, so once you find the area, you see what I put in here for the integral? So from
Yeah.
-2 to -1, so find the area from the curve. Again, by using the geometric formula. And then you just want to compare the area. So whatever the area that shows the highest, the biggest number, so that it's going to be the absolute maximum. Again, see that from -2 to x. Okay, so from what we don't know what x is, so that's why we need to compare all the zeros, all the area from the 0, from -2 to -1, and then from -2 to 0.5, and then from -2 to 5. So eventually you'll see that the area from -2 to 5 will give you the largest number, and that shows the maximum area. And that means at t equals 5, and it's the position where we can find the absolute maximum, which is 11 minus 9 power 4.
So when you're justifying it, you can just like write a statement when you compare them.
Yeah,
like,
you
for
can
different
just
areas.
write a statement, but you still need to do the calculation first, okay?
Okay.
So such that the area from -2 to -1 is so, and then -2 to 0.5 is that. And then by doing comparison, so we find out the area from -2 to 5 will give us the maximum area. So that means at 5, t equals 5, and that's the position the graph shows the absolute maximum.
Okay.
Okay, makes sense?
Yeah.
Okay, so now let's see. According to the College Board, do you guys are going to be tested with Taylor series, Maclaurin?
Just Taylor, I think, not McLaurin.
Just
If I
Taylor, not
remember.
Maclaurin? Okay.
Right, guys? Or am I wrong?
I don't know.
Okay, well, I'm
'Cause I
going to show
rem-
you that too, okay? So
Okay.
let's see what we got for the next one here. Okay, the volume related rate. Okay, so just read through it first. Again, the key word, the key number is very important. So the radius for this barrel, so that's just considered 1. The one that's given there, that's just a diameter. So make sure that the unit got to be consistent. So that's just 1 foot. Okay, so here's what we got for dH over dt. So this one, it shows the literal equations. It's -1/10 times square root of h. And obviously the volume for the cylinder, it's pi r squared times the height. Okay, so let's see what we got here. Okay, so now the first question, find the rate of change of the volume of water in the barrel with respect to the time when the height of the water is 4 feet, and indicate the unit of measure. Okay, guys, keep that in mind. The radius, that's not the variable, that's a constant. So how do you set up the volume equation for this? Okay, anyone?
It would be height as like the variable.
Yeah, the height,
that's
it's
getting
only
to the rate of
variable.
change.
Height and the volume, those are the 2 variables. Okay, the radius, it's a constant.
So then it would just
So
be
that
like,
means V equals pi, well, 1 square times 1 square times the
it's
height.
just pi
And then
times
from
H.
there, you want to take the derivative, right?
Yeah, times.
So that
yeah.
means dV over dt. So that equals pi times dH over dt. So instead of using dH over dt, excuse me, so you want to put in that -110 root h, okay? So that means pi times -1/10 times h to the power of 1/2. Well, it's the same thing as square root of h. And then you plug in the height. So what's the height here? 4 feet. So basically plug in the height. So pi, so -1/10, and then 4 to the power of 1/2, that's 2. So -2/10, which is -1/5. So it's going to be what? -0.2 pi. Okay, let me just check the answer here real quick. Okay, so this one's number 4. Yeah, that's what I got. So eventually it's going to be negative pi over 5. And we do know that's the rate of change of the volume. So it's cubic feet per second. Okay, so any question that you have for the first part of number 4 so far?
No,
Anyone?
I'm good.
Good. Okay, that one's pretty straightforward. Okay, so now what about the next one? When the height of the water is 3 feet and the rate of change of the height of the water with respect to time, increasing or decreasing? And explain your reasoning. Okay, so let me just get rid of this thing here, annotation. Okay, so anyone, any thought? Again, so the height of the water now this time is 3 feet high. And you want to find out the rate of change of the height. So dH over dt again. Well, this one, you want to find out whether that's increasing or decreasing. So it looks like we have to do some kind of like a derivative test. Okay, anyone, any thought?
Could you plug in 3 and then if it's negative, then it's decreasing, or do you have to do more work than that?
Yeah, you have to do more work for that. Okay, that's a good thought. Okay, that's a good thought, but the thing is that you have to do a little bit more work for that. So one thing that we noticed, so started with that dH over dt. So this one is given as negative 110, and then h to the power of 1/2, right? So you guys all agree?
Yeah.
Yeah.
Okay, so now check this statement right here. The rate of change of the height. You want to find out whether that's considered increasing or decreasing. So that means you want to take the derivative of that dH over dt with respect to the time. So if you try to take the derivative of this, so what do you end up for the derivative with respect to the time?
Yeah, negative 1/10 times
Negative 110 times 1/2,
1/2
and then
h
h to the power of negative 1/2, and then using the chain rule or implicit differentiation, and then what else? dH over
dt.
dt, right? So basically this one you want to plug in that dH over dt here again. So try to simplify it all the way through. So here's what I found. So it's going to be considered negative 110 h to the power of 1/2. Okay, so that's just dH over dt, and then times the original derivative right here. So then that would be considered negative 1 over 20, and then times h to the power of negative 1/2. And then you plug in the time, the height. Well, there's no need to plug in the height because this one got canceled out. Okay, so this one got canceled out. What's left?
Yeah,
It's just
negative
negative 1 over
200.
200, right? So now it's a negative number. So what does that tell you? What does that indicate? So what happens with the rate of change of the height? Is that considered decreasing or increasing?
Decrease.
Decreasing. Good. So this one basically is just like going back to derivative line tests. So if the rate of change of the height it's considered negative, I mean the derivative is negative, that means the rate of change of the height it's considered decreasing. Okay, makes sense?
Oh, isn't there another negative?
Which negative?
Because you have
Oh yeah, wait a minute. Sorry about that. Okay, wait. Negative times negative, then that'd be what? We missed that
positive,
negative right here,
right?
positive. So instead of being decreasing, so this one is what? It's actually
Increasing.
increasing. Thank you.
Okay.
So let me erase that part. Okay, let's see. Good. And what about for part C? At time t equals 0 second, and the height of the water is 5 feet. And use separation of variable to find expressions for h in terms of t. And guess what you have to do with that one?
Oh,
So you want to find find a height.
Integrate.
Yeah, so basically using that dh over dt and then separate the variable and then integrate it, right? So negative 110 h to the power of 1/2. So that means dh equals, how do you separate it?
Cross multiply
Cross multiply it, okay. So that means dh,
is 1 over root h.
okay, root h. So that equals negative 110 dt, right? And then the rest of that, I just want to integrate it. But the thing is that make sure that you need to solve for c. So after you integrate it, both sides, so solve for c first. So how do you guys solve for c? What's the initial condition here?
When t equals 0.
Right here, 0, comma what, 5, right? So by plugging that number, and then you can solve for c. So that one is pretty straightforward too. Okay, so let's just integrate it. So integral. So integrals of h to the power of negative 1/2, which is what? H to the power of 1/2 multiplied by 2, right?
Mm-hmm.
So that equals negative 110t plus c. And then from here, you can just solve for c first. So plug in 0 and 5. So 0, well, 2 times 5 to the power of 1/2. So that equals c. So the value of c is 2 root 5.
We have
Right?
to isolate h, right?
Yeah, well, eventually you need to isolate h, but I'm just showing you
yeah.
that just solve for c.
Okay, yeah, no, I was just wondering. Yeah.
Eventually, and then just plug in the number and then solve for h. Yeah. So eventually, so h would be considered, well, h of t. So that's written as negative 1 over 10t plus 2 root 5. And then divided by 2, right? And then quantity square. Or you can just simplify that a little bit first. Yeah, you can do it that way too. So that, and then quantity square. You can just reduce it, so negative 1 over 20t, and then plus root 5. So quantity square. All right, so you guys okay so far?
Yeah.
Yeah? Anyone?
Yeah, that's good. Yeah.
Any other people? Questions? So far, only hear Arthurvin, and also who is that? Is that Lucas?
No.
That's Jet.
Oh, Jet.
Jet.
Okay. Hey, what about Essen? Any questions? Let me unmute the other people here. Excuse me. Let's see. Okay, Kenny, any questions?
I'm good.
You good?
Yeah.
Ishan,
I'm good.
you good?
I get it.
Dylan?
I'm good.
All right, cool. Andrea?
I'm good.
All right. Okay, so now let's see the next slide here. Okay, so consider the family of a function, f of x. So 1 over the quantity of x squared minus 2x plus k. So where k is a constant. So find the value of k. So where k is greater than 0, such that the slope of the line tangent to the graph of f at x equals 0 equals 6. So the slope is 6. So what does that tell you? Anything that's being indicated here?
So when you take the derivative and you plug 0, then it equals 6.
Right. And then from there, you want to solve for k, right?
Yeah.
So basically, take the derivative, f prime of x. Okay, so derivative of that by using the quotient rule. Or you can just simply take the derivative with the power rule. So for f of x, you can always rewrite it as x squared minus 2x plus k quantity to the power of -1. So instead of using the quotient rule, just use the power rule. It's easier. So -1 times quantity of x squared minus 2x plus k to the power of -2, and then the chain rule. So multiply by 2x minus 2. And then you want to set that equal to what? 6. And then from there, you want to solve for k. Again, 0, make sure that you plug in 0 for x. So 0, 0, so that turns out to be nothing here. So we left with k to the power of -2. So let me just rewrite it. -1, k to the power of -2, and then times -2 equals 6. And then from there, you want to solve for k. So divided by 2 both sides, so k to the power of -2, so that equals 3. So that means k multiplied by -1/2 on the power, so it's 3 to the power of -1/2, which is what? 1 over root 3? Or root 3 over 3. Is that what we got?
Yeah.
Cool. Okay, so now for the next one, so for k is -8, find the value of the integral from 0 to 1 f of x dx. So that one, basically, guess what you have to do? Integrated by?
A partial fraction.
Exactly, integrated by partial fraction. Good. You guys know how to do partial fraction, right?
Yeah.
Yeah.
That's good. So that's the one. We can skip that. And then for k equals 1, so find the value of, okay, so basically plug in a number, show whether that's convergent or divergent. So this one basically just using the what? The improper integral? The improper integral test. Okay, so let me just set it up here. So integral from 0 to 2. So 1 over x squared minus 2x plus 1. Okay. So for the previous one, I tried to do the partial fraction. This one turns out to be integral from 0 to 1. And it's 1 over x minus 4. And then x plus 2 dx. Okay. So basically this one just integrate it. Okay, so integral. I mean, the things that you want to separate it because that you cannot plug in -2. Well, let's see. Wait, hang on a second. No, that's right. That's for part.
Right.
Yeah, this one's for part B. And then for part C, so you want to integrate it. Just factor it. So 1 over x minus 1 quantity square from 0 to 2.
Wait,
And then you want to break it apart from 0 to 1. Right? And then the other part right here, it's from 1 to 2. So basically, it's just the improper integral, and then you take a limit, as x goes to 1 from the left, and the other one is limit as x goes to 1 from the right. And then eventually it shows this one as this one eventually shows the limit, it's going to be -infinity. So therefore, it's going to be considered diverge.
Wait, Mr. Chen.
Uh-huh.
Why do we split it up into 0 to 1 and 1 to 2 when we can just? Oh wait, never mind.
Right here.
My bad. No, I got it.
Right.
Yeah, my bad.
Because the restriction or the domain. Yeah. So basically, this one just take the limit. Eventually, take the limit as x approaches from the left, and this one take the limit as x approaches from the right. So one shows that it's going to be -infinity plus another -infinity. So eventually, it's going to be -infinity. So therefore, it's what? Divergent. Okay. Anyone? Any questions so far?
No.
No? Okay, let me just check that for the rest of the folks right here. This one. Okay, so now let's see what else that we have. Okay, so now number 6, the last one. So this one is about the Taylor series. So given with the graph, the tangent line, and also this one shows the high order of derivative at 0. So derivative, the second derivative at 0 is 3. And the third derivative at 0, it's negative 23 over 2. And then the fourth derivative at 0 is 54. Okay, so here's what we got for the function. So the first one, you want to write the third degree Taylor polynomial for f at x equals 0. So what's the Taylor series again? What's the general formula? Can someone tell me what that is?
It was x minus c to the n power times
Okay.
f to the n derivative of 0 over
Right.
n factorial.
Okay, so x minus c. Excuse me, let me just put in the over 0 factorial, and then plus
F to the n derivative of 0.
Well, make sure that I put in that
It'd be multiplied.
multiplied by f of 0.
Yeah.
Okay, and then the next one, f prime of 0, right? And then x minus c to the first power over 1 factorial. So this one is basically just kind of like a sequences in series. And then f double prime of 0. And then x minus c quantity square over 2 factorial, so on and so forth. Okay, so basically this one just plugging a number. Now, but the thing is that the first derivative at 0 is not given. So we need to find out what that is from the graph. Okay, so can someone tell me about the rate of change at this position right here? What is it?
-2.
-2? It is. So 4 unit down, 2 unit to the right, so it's -2. So basically just plug in a number. And then f of 0, that's what, 3? Okay, so x minus c. Well, the first one is 0 minus c, so 0 minus 0, so that's nothing. Well, that's just what? What's x minus c right here? Well, the first one, actually, we don't have to say that x minus c, so that just 3. Okay, let's see the x value, which is what, 0? Okay, so now what about the next position, f prime of 0? -2, right?
Yeah.
So basically just -2 times x. Again, the value of c, that's 0. Okay. And then the next one, f double prime. So we're using this one, which is what, 3? So 3 over 2 factorial. And then times x minus c. So just x squared. Again, c is 0. Okay, how many terms do we need to put in for this one? Third degree polynomial. So this one is the second. We need one more term. So the third derivative, which is what? -23 over 2 over 3 factorial. And then times x to the third power. Okay, so that's the first one for A. Again, it's all about using the formula, the Taylor series. Okay, anyone? Any questions?
Wait, so the 3 doesn't count as Because
Yeah.
you wrote 4 terms, but it says to the 3rd degree.
Yeah, to the 3rd degree. So that means the power. Okay, so this one is to the x to the 3rd power. Okay, because this one's being cut off a little bit. Let me just show you this. Okay, let me just write the 4th term. So if that's a 3rd degree, that means you need to show the first 4 terms. Because that's a polynomial.
Okay.
Okay, so that means the 3rd derivative. So we got negative 23 over 2, and then over 3 factorial times x minus c, quantity to the power of 3, which is what? X to the 3rd power. Well, this one you can simplify it a little bit more, but I just want to show the whole thing.
Okay.
Make sense?
Yeah.
Yeah? Okay, so the next one, I don't think you guys are going to have a Maclaurin series, right?
Oh yeah, all of it I checked. There's no McLaurin.
There's no Maclaurin, but Taylor?
Yeah, that's what I thought. All right, cool.
Yeah.
Okay,
I'm
so
good.
that one for part B, we can skip that one. Okay, yeah. Because
What about the
Maclaurin, there's
second
certain
degree
formula that I need to recognize, like e to the power of x, all that. And then sine, cosine,
What about the second part of B? Like write the second degree Taylor polynomial for e to the
Write a
x.
second degree Taylor polynomial for, okay, yeah, let's do that. So for that one, again, so e to the power of x, so, okay, so this part right here, so let's say that we don't need to expand it with the Maclaurin, okay? So we skip that part. So we just write it with e to the power of x and then times whatever that we set up here. So we just want to put it in. So 3 minus 2x and then plus 3 over 2 factorial. So then that'll be considered 3 over 2 x squared. And then over here, so 3 factorial, which is what, 6. So 12. So negative 23 over 12. Okay, I need more space there. So basically just like plugging the Taylor series, the one that you set up for A. Okay? So negative 23.
Okay.
I put in the negative sign already. Okay, so minus 23 over, what is it? 6. And then x to the power of 3. And then you want to find what? Find the, just write a second degree. So normally Maclaurin, so this part right here, you have to recognize like part, one of those formula for the expansion for the Maclaurin series. So for e to the power of x, this one you don't need to know, but I just want to show you that. It's like 1 plus x squared over 2, and then plus blah, blah, blah. So once you multiplied it, so you just want to, either you want to FOIL it or you want to find the pattern there. But so far, if that's just asking about the Taylor series for this, so just show the word like that.
Mr. Chen, shouldn't it be negative 23 over 12?
Negative 20, yeah, negative 23 over 12, sorry. Because that's what, 2 times 3 factorial. Great. Yep. Good.
Wait, if it's second degree, don't we stop at 3/2 x squared?
If that's second degree, let's see. According to the instruction, yes, to the second degree, you just stop right there. Good. So second degree, you just stop right there. So for that part, and just stop right there. Good. Who is that? Is that Jet?
No,
it's
this is
Dylan.
Dylan.
Oh, Dylan. Good job, Dylan. Okay, so now what about for, let's see. So let h be the functions by, okay, well, that one is just like doing the integration. Okay, so nothing special. So that one is just like integral from 0 to 1. And then the one that you find in part A, so basically just integrate it term by term. 3 minus 2. Well, instead of using 2x, it's 2t. And then plus 3 over 2 t squared. And then plus negative 23 over 6. Well, 12, excuse me. So again, it's just a setup. Once you know how to set it up, the rest of this is just like basic calculation. And then t to the power of 3. And then to the integral.
Wouldn't it be 3 over 2 factorial t squared?
Wait, which part are you talking about?
The third term. 3 over 2 factorial t squared instead of 3 over 2 t squared.
2 factorial is
Oh yeah,
What's
that's
the
right.
factorial of 2 then?
What? 2 factorials? 2?
Oh yeah.
That's
yeah,
just
that's
two, right?
correct.
Yeah.
Never mind.
We just we just want to simplify it. Yeah.
Okay.
Okay, so now the next part right here, let's see. So it's known that the Maclaurin series for h converges to h of x for all real number. Again, it's not Maclaurin, don't worry about it. It's also known that the individual term of the series, h of 1, alternate in sign, okay? So that one is kind of like a what? It's like an alternating series, right? You try to expand it. So alternate in sign and decrease in absolute value to 0. So use the alternating series error bound to show that the approximation found in part C differ from h of 1 by at most 0.45. Well, this one, don't worry about it. This one is kind of like a Lagrange. But the things that if you guys don't worry about the Maclaurin, there's no need to worry about the Lagrange. You try to expand out let's say that you want to put in the fourth term, and then with the previous one that we found for part B. So this one, eventually, you'll end up with the term like 54 over 4 factorial x to the 4th power. And then whatever the last term that you have, so this one's considered a Lagrange. So you want to show that integral from 0 to 1. And then eventually it shows that the approximation error, so that would be 0.45. Okay. Again, this one you have to do that expansion with the Maclaurin series with this. So once you expand it out to find the pattern, you'll get the 4th power, which is like this. And then you take the integral. So the last part, you don't have to worry about it. So since there's no Maclaurin series. Okay, so any questions, any concern that you have?
No.
No?
Sure. No, not to the second thing.
Okay, so another thing, just want to ask you about the permission. Do you guys mind that I put up this for the YouTube video so you guys can watch that later on my YouTube channel?
Yeah.
Yeah, is that okay? Yeah, because I
Yeah,
just want to get your
fine.
permission because you know your voice is there in the video. Is okay?
Yeah.
All right, sounds good. So you guys can watch those later. All right.
Cool.
Yeah. So any friend
you.
that taking the test, AP Cal, the BC part, just let them know. And also even for the AB, there are certain questions that they're similar. They're exactly the same. Like for the free response, like the first calculated problem, and also the non-calculated problem, also they're kind of exactly the same. Okay, so if anyone taking that AB from the other school. Okay, so, and in the future, I'll probably set up the Zoom meeting for another free response training practice. If you guys are interested, I'll let you guys know.
Okay.
All right?
Right.
Yeah.
Okay, so sounds good.
Right.
So I'll see you guys next time. All right? You guys take care.
Thank
All
you.
right.
All
Thank
right.
you, Mr. Chen.
No problem.
Thank you.
Yeah,
Thank
no
you.
problem.
Thank you. Have a good day.
You
Have a
too.
good day.
Bye.
Bye.